Hi, also today's video we're going to be looking at arithmetic series, okay, which looks to sum the arithmetic sequences we looked at previously. So we're going to let Sn be our notation. That's going to stand for the sum of an arithmetic series, okay, and that's going to denote the sum of the first n terms of the general arithmetic sequence, okay, with first term still being A and common difference being D. Okay, so the first one is going to prove what the formula would be. So in an arithmetic series, sequence I should say, we've got the values A, that's our first term. Then we've got our second term, which we get by adding D to our first value, so A plus D. And then we've got A plus 2D, and then A plus 3D, and so on, okay, all the way up to how far we want to take it. So let's say I want to sum the first n terms in an arithmetic series, okay, so that means I'm doing A plus D, so I'm just adding all my terms. I'm going to put that in brackets there, plus A plus 2D, plus all the way up to. So remember that the last term is n, so the last term, how we would find that would be A plus n minus 1 d. Okay, that's how far that series would go up. Okay. Now, I could also sum this from the reverse point. I could actually start with the biggest one and work my way down. But the last term, so I could do A plus n minus 1d plus A plus, the term before that being n minus 2d, okay, plus all the way to A plus D plus A. Okay, so I could do that both ways. Okay, I don't have to start at the first, I could start at the end if I wanted to, okay, if I knew all the terms. Now what we're actually going to do is we're going to add these two things together, so two lots of the sum. Okay, so I'm doubling the sum because I'm adding them both together. Okay, and then you can see if I add sort of in line with each other. So in other words, the first one was A in that first sequence, and it was A plus n minus 1d in that first one in the second way we can summarise it. So that would end up being, well, the a's would add together, so 2a plus n minus 1d. Okay, I'm just adding these two terms together here to get what my first term would be when I add them together. Okay, if I do that with the second one, so I'm adding an a plus a d onto that, so that would then be 2a plus n. Well, I'm going to add a d to that, so it's going to be just n minus 1 lot of d there. Okay, so I get that there as well. Okay, and then so on and so forth. And what you should see is, okay, even if I go down to the very last terms, that all the terms would be 2a plus n minus 1d. Okay, so if I've got then n amount of times, so I've done it for n terms, that means this two lots of the sum would be n times 2a plus n minus 1 d. Okay, so that's what every bracket would be. I'd have them n times. So if I want the sum though, not two lots of the sum, I'm just going to divide by 2, so it'd be n over 2 multiplied by 2a plus n minus 1 d, like that there. Okay, and that there is the formula we're going to be using, and it is on your formula sheet. Okay.
Where'd you get the two from the last bit?
So the last terms, good question. So the last terms, okay, was these two terms here. They were the last two terms in both the sequences, right? If I add those together, so I've got a plus n minus 1d, and I've got an a to add on to that, that means that a is going to join that a to make it two lots of a. So therefore I've got two lots of a in every single one. Are you asking me about why I've got n over 2 here?
Yeah.
So remember, because I had two sequences that were summing both the same thing, when I added these together, I need to spot that I'm adding the sequence twice. So I've got two lots of that sequence. Yeah, I've got two lots of that sum. So then I divided by 2 to get just what the sequence would be. Alright, so that's what we're going to be using today on our formula list, and that's how we get it. Okay, so let's have a look at a couple of examples to see how we can use this. Now, you've all been able to calculate for many of these questions. Okay, not them all, but many of these questions, because the numbers do get quite sky high. So let's look at example 1. So for the arithmetic sequence 2, 5, 8, 11, so on. We want to find the sum of the 15th term to the 35th term. I've got to write in brackets both terms inclusive. Okay, so we're including the 15th and the 35th as well. Okay, so what I'm asked to do is I'm asked to find the sum between the 15th and the 35th term for that sequence there. Okay, so how do we do it? Right, solution. So from the sequence, okay, 2, 5, 8, 11, we should be able to spot what A and D are, our two values. Okay, so A is obviously our first value in the sequence. A is 2, and D will be 3. The values are going up 3 every time. The difference is 3. Okay, so we get that from the sequence there. So if I put that into my formula that I've got for the summation, so let's do it now for the 35th term. So what this is doing, this is going to sum the first 35 terms, okay, all together. Okay, so it's going to include all the terms all the way up to the 35th term. So that's going to be 35 divided by 2. Okay, because it was n divided by 2 at the front. Multiply 2 lots of A, so that's 2 lots of 2, plus n minus 1, okay, well that's 35 minus 1, times our difference D, and I've got to work that out there, okay, so I've just substituted that into the formula that we wrote down earlier on, okay. If I then tidy this up, so that's going to be 35 over 2, multiplied by 4 plus 34 times 3, okay, and that gives us the answer, if you've done that in a calculator, 1,855. Okay, so that's me summing what the first 35 terms would be. However, our question asked us though, can we find the sum of the 15th term to the 35th term? So we don't want to include every single term here. Therefore, I need to exclude the sum of the first 14 terms. They need to come off this. Okay, so I need to work out what the sum of the first 14 terms would be. Okay, again, using my formula. So it's going to be 14 divided by 2. 2 lots of A, again that's 2 lots of 2, plus n minus 1, well that's 14 minus 1, times the difference 3. 14 divided by 2 is 7, 2 lots of 2 are 4, plus 13 times 3. And that gives us an answer of 301. Okay, so that's the sum of the first 35 terms, 1,855. The sum of the first 14 terms was 301. So therefore, if I take them off, I'm going to start at the 15th term. So S35 take away S14, 1,855 take away 301 will be 1,554. Okay, so that's what the sum of the 15th term all up to the 35th term would have been for that arithmetic sequence. Okay with that first one there? Okay, so that's just using the formula. Let's look at a second example where we're asked a little bit more here. Okay, so example 2. Okay, so find the sum of the series okay, and we've got 6 plus 7.6 plus 9.2 plus 10.8 plus all the way up to 49.2. Okay, so my job here is to find what the total of that sum, that series would be. Okay, now again, the long way to do this would be to fill in the blanks and find all the numbers out and then do that, but there's a much more efficient way to do it. Okay, again though, the good thing is from our values, okay, we can see what A is Okay, A is a starting off point, A is 6. That's the solution. And D is a difference, and in this case, every number's going up 1.6. Okay, so we've got that. Now I want to do the sum of all these numbers here. In other words, I need to know, that's my first term, but I need to know how many terms are in this sequence. So I need to know what term that 49.2 was. Okay, so I need to use what we looked at in the previous video. I need to know that U of n equals 49.2. Okay, that's my last number, that's what the last term would have been. But we also know that U of n equals A plus n minus 1d. Okay, that's how you find any term in an arithmetic sequence. So I'm going to make that equal to 49.2, and I'm going to substitute in my values for a, so that's going to be 6 plus, okay, again, I don't know what n minus 1 is, but it's going to times d 1.6. Okay, so that's what I've got there. Now, if I multiply this bracket, 1.6 times n is 1.6n, take away 1.6, and then 49.2 would be 1.6n plus 4.4. Okay, 1.6 would come off that 6. Okay, if I subtract 4.4 off, that's going to give me 1.6n equals 44.8. And if I divide by 1.6, I get the value 28. Okay, I calculated below for that last step there. Okay, so that was the 28th term. That's what I've managed to work out. So that tells me how far and what value of n I put into my sum. So the sum of the first 28 numbers, okay, so remember it's n divided by 2, so it was 28 terms, so that's 28 divided by 2. That multiplies 2 lots of a, so that's 2 lots of 6, plus n minus 1, so that's 28 minus 1, times d, which is 1.6. Okay, bit of a squash there. That becomes 14. That needs to multiply 12 plus 27 times 1.6. And if I do that, I get the answer is 772.8. Okay. So that second example showing you that you might sometimes have to work out what term this one's going up to. In our case, it was the 28th term that series went up to. Then once we've done that, we just shoved everything in the formula to get the answer out. Are we okay with those first two examples? Right, let me show you what can be a very common question regarding working backwards. Okay, so we'll look at, let's scroll back down. Let's extend the page. So let's look at example 3. So we want to find a formula for Sn, okay, our sum, which is the sum of the first n terms of the sequence nine, 15, 21, 27, and so on. Okay. Hence, find the least number of terms which must be taken to give a sum exceeding 10,000. Should I spell this out? Exceeding 10,000. Okay, so there's two parts to this question. The first thing we want to do, we want to find a formula for what the sum would look like for any terms we'd want, up to n terms, and then hence we need to use that to then find what least amount of terms we would need in order to make the sum go past 10,000. Okay, so a bit more of an extension question here. So let's look at the solution for this one. So again, from the sequence 9, 15, 21 and 27, we can see that A here is 9. Okay, so that's our first value. D is a difference. D is 6. Okay, so we're good to go. Okay, we've got those two parts. Now we know what the sum formula looks like. So Sn equals n divided by 2 multiplied by 2 lots of A plus n minus 1 D. With 2 cents. Oh, sorry. H2, no, A wasn't in. Oh, thanks, bye. Sorry. So that's our formula that we've got for working out the sum. Now we're going to substitute the values of A and D into that and then tidy up. So that's going to give us our formula. So it's going to be still n over 2 multiplied by 2 lots of A. That's going to be 2 lots of 9 plus n minus 1 times 6. Okay. Tidy that up. That's going to give me 18 plus 6n minus 6. Okay. Extend that space. There, more space, a little bit. And then n over 2, that's going to be 6n plus 12. Okay, so I've managed to tidy up what's inside my brackets a fair bit. Good thing is, I can divide everything by 2, that's what that half at the front's doing, just times everything by n, so that's going to give me 3n squared plus 6n. Okay, so that's my formula for the sum. Okay, it doesn't matter what amount of terms it would be. If I knew what n was, I would put into that and I'd be able to get the sum for those terms. Now, second part is we're then asked what values can we least have in order to exceed 10,000. Okay, so in other words, what would be the first number of numbers we'd have that would go past 10,000? So let's make our sum equal to 10,000. Okay. So that's what we're going to make equal to 10,000. Now you want to solve this, so we're going to bring it over to the left hand side and make it equal to 0. Alright. Now, if you were a very, very, very patient person, you could try your best to factorise that, but that would be an absolute nightmare to try and factorise. Okay. What you want to do here is use the quadratic formula in order to get your two values for n here. Okay, so we're going to let A equal 3, B is 6, C is negative 10,000. Okay, so quite involved here. We better check that we actually have solutions first of all. So B squared minus 4AC, that's going to become 36, take away 4 times 3 times negative 10,000. That's going to become 36 plus, the negatives cancel, 4 times 3 is 12, times it by 10, that's going to be 120,000. So we get 120,000 and 36. So that's what's going into our B squared minus 4AC. So let's get our n value. So n equals negative b plus or minus square root. It's going to be 120,036 now. Divided by 2 lots of A. So that's going to be negative 6 plus or minus square root 120,036. Try and knock that out again, that doesn't look too good. 36. All divided by 2 lots of A, which is 6. Okay. And solving this, you get two values, n equals 56.7 or n equals negative 58.7. Okay, so we've got our two values there. Now remember, n is the amount of terms, so it doesn't make sense that we have a negative value. Okay, we can't use that one there. So we're going to let n equals 56.7 as the only valid solution as n needs to be positive. Okay. Now obviously there's no such thing as a 56.7th term in this series, so we have to go up to the next value, so n would be, we need 57 terms until the sum exceeds 10,000. Are we okay with that?